Good morning, students. Welcome back, you all, to the online classes of chemistry. According to the new syllabus of this session, we have completed the topic Nature of Matter and its subtopics also. Now, our next topic is particle nature and their basic units. In this, the first subtopic is atoms and molecules. Before starting this topic, let us learn how these two terms, atoms and molecules, came into existence. So let's start. Ancient Indian and Greek philosophers have been thinking about what matter is ultimately made up of. It was around 500 BC that an Indian philosopher, Maharishi Kannad, had suggested that if we goes on dividing matter, we will get smaller and smaller particles of matter. At last, a stage will come where the particle of matter cannot be divided anymore. He gave these indivisible particles named as Parmanu. Almost during the same period, ancient Greek philosopher Democritus and Leucippus also gave the same idea, and they called these indivisible particles as atom. So, dear children, we can say that the smallest particle of matter which cannot be divided anymore, they are termed as atoms. Another Indian philosopher, Pakhuda Katyayama, postulated that atoms cannot exist in free state, but they exist in a combined form. This combined form of atoms is called molecules, or in other words, we can say that the group of atoms is itself a molecule. Hence, the properties of matter depend on the properties of atoms and molecules from which it is made. Till the 18th century, all these assumptions were carried on, but by the end of the 18th century, that fact had been established that why the elements combine together to form compounds. Experimental studies were carried out to understand the laws according to which the elements combine to form compounds or substances react together to form products. These laws are called laws of chemical combination. Next is laws of chemical combination. There are two laws of chemical combination which was given by Lavoisier and Joseph L. Proust. First one is law of conservation of mass. It was formulated by Antony Lavoisier in 1774. According to this law, mass can neither be created nor destroyed in a chemical reaction. Or, in other words, in any chemical reaction, the total mass of the reactants is equal to the total mass of the products. Now, the question is, what are reactants and what are products? So, my dear children, what are reactants? Substances that takes part in a chemical reaction is called reactants, and they are always written on the left side of the chemical reaction. Okay? Now, what are products? The transformed form of reactants are called products, and they are always written in the right side of the chemical reaction. To understand this law, let's go through an activity. See the activity. Take one of the following sets X and Y of chemicals. Here I am taking barium chloride and sodium sulfate as an example. See the picture. Figure 3.1. What you have to do in this, you have to take one conical flask and mix 5% of sodium sulfate with water. Okay, and inside that flask you have to put one ignition tube. Ignition tube. Now, what is ignition tube? It is a hard glass test tube mainly used for heating purposes. You have to put that ignition tube inside the conical flask with the help of thread and also put a cork on it and leave it for few seconds. Then what you have to do? You have to take the weight of the flask. Okay. Now after some times you have to twist the flask so that the solution of barium chloride and sodium sulfate gets mixed. And again what you have to do? Again you have to take the weight of the flask. So by doing this activity, what result we got? We will see chemical reaction is taking place and barium chloride and sodium sulfate is transformed into barium sulfate and sodium chloride. So, by this activity, we can prove that mass can neither be created nor destroyed in a chemical reaction. Now, next law is law of constant proportions. Law of constant proportions is also called as law of definite proportions. It was put forward by J. L. Proust in 1799. According to this law, a chemical compound is always made up of the same elements combined together in the same fixed proportion by mass. To understand this law, let me explain through you an example. Water obtained from any source like river, rain or tap etc. and from any country is always made up of the same elements, that is hydrogen and oxygen combined together in the same fixed proportion, that is 1:8 by mass. This can be checked by taking 9 gram of water from any source and then decomposing it by passing electricity and collecting the gases formed, we always get 1 gram hydrogen and 8 gram oxygen. According to this law, whatever ingredients is necessary to make water is always constant. Means when we are making water, we always use hydrogen and oxygen in the fixed ratio, that is 1 is to 8. The ingredients and the fixed proportion cannot be changed. This is the law of constant proportion. These two laws of chemical combination were put forward by British chemist John Dalton. The theory is based on certain postulates called postulates of Dalton's atomic theory. So let's see what are the postulates of Dalton's atomic theory. Before starting this theory, let's see who is John Dalton. John Dalton was born in a poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12. 7 years later, he became a school principal. In 1793, Dalton left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was a turning point in the study of matter. So, let's see the postulates. Number 1. All matter, whether an element, a compound, or a mixture, is made up of extremely small particles called atoms. Point number 2. Atoms of the same elements are identical in all respects, that is, size, shape, mass, and properties. Third one, atoms of different elements have different sizes and masses and also possesses different properties. Fourth one, atoms of the same or different elements combined together to form molecules or compound. Fifth one, the number and kind of atoms in a given compound is always fixed. Sixth one, an atom can neither be created nor destroyed, that is, atom is indestructible. John Dalton has explained the laws of chemical combination for conservation of mass as well as law of constant proportion. For law of conservation of mass, he said that matter is made up of atoms and it can neither be created nor destroyed. It is the smallest particle that takes part in a chemical reaction. The total mass remains unchanged during a chemical reaction. And according to him, law of constant proportion states that the number and kind of atoms in a compound is fixed. The elements are combined in a fixed ratio by mass. Hence, the law of constant proportion is used to calculate the percentage of any element by using this expression, and the expression is percentage of an element in the compound is equal to mass of that element divided by mass of the compound multiply 100. Let's see one example based on law of conservation of mass. When 4.2 gram of sodium hydrogen carbonate NaHCO3 is added to a solution of hydrochloric acid HCl weighing 10.0 gram, it is observed that 2.2 gram of carbon dioxide CO2 is released into the atmosphere. The residue left behind is found to weigh 12.0 gram. Show that these observations are in agreement with the law of conservation of mass. Here you have to prove that mass of products is always equal to mass of reactant. So here HCl and NaHCO3 are reactants, so we'll add. What result we got? 14.2 gram. Here the values are given in the question itself. Now we will follow the same rules for products also. We will add mass of residue and CO2 by seeing the values from the question. What result we got? 14.2 gram. In both cases the answer is same, so we can say that mass of product is equal to mass of reactants. This proves the law of conservation of mass. Now see one more example based on law of constant proportions. Copper oxide was prepared by two different methods. In one case, 1.75 gram of the metal gave 2.19 gram of oxide. In the second case, 1.14 gram of the metal gave 1.43 gram of the oxide. Show that the given data illustrates the law of constant proportion. Here we have to prove law of constant proportion. As per question, the values are given in the question, so we will write the values first. Mass of copper 1.75 gram, mass of copper oxide 2.19 gram. So by applying the identity, percentage of copper in the oxide is equal to mass of copper divided by mass of copper oxide into 100, and by putting the values and by solving it we will get 79.9%. As per question, oxide is there, so the percentage of oxygen is 100. So we'll multiply the answer, that is 79.9% with 100. We'll get 20.1%. Same rule we will follow for the case 2. And by comparing the answers from case 1 and as well as case 2, this proves the law of constant proportion. So next class we will move on to the next topic. Okay, thank you children.